Hello all, today we will be dealing a topic in operating system which is related to deadlock. So, in this class we will be covering what is a deadlock, what are the necessary conditions for a deadlock and what methods we will be using for handling a deadlock. So, first we will see what is actually a deadlock. Now, when I go for a multiprocess, we have already seen what is multiprocessing. We now see here if I have two processes and these are the resources associated with that particular process. And in operating system, as we all know, a resource can be a hard disk, a resource can be a tape drive, a resource can be a CPU, anything. So now if a particular process, as you can see in this diagram, this process is being assigned a resource 1 and this is in turn waiting for other resource 2. Similarly, when I move on to the second process is waiting for a resource 1 and it is being allotted resource 2. Now one process is holding a resource and waiting for the other resource. Similarly, process 2 is also holding a resource and waiting for the other. So, in this case, neither of the process can continue their execution. So, since both of them cannot continue the execution, we call this particular process as a deadlock. Now, we will see the real time examples. Now, for example, I have two persons. Person 1 think it is as a process 1, person 2 think it as a process 2. And I have two resources here. One resource is nothing but the printer, the other resource are nothing but the papers. And both these persons want to perform a task. The task is they want to take a print. Now, one person is having a print but he is not having any papers. So, he will be waiting for the other person to give the papers. Similarly, person 2 is having papers but he don't have the second resource. Neither of them can continue their job printing. So, this is a normal example where it leads to deadlock. Similarly, when I see this particular example where you have these 4 cards which are nothing but your process. Now, each of them are using a resource. This lane is pertaining to this particular car, this lane is pertaining to this and this lane is pertaining to this particular car. So, these lanes are nothing but your resources and the cards are nothing but your process. Now, in this particular case, if all of them want to use the other resources which is available, you may be encountering a traffic jam which is nothing but an example of a deadlock here. So, these are some real time examples where we actually encounter a deadlock. So, ultimately deadlock, by seeing this example we could understand that deadlock is nothing but a process will be holding a resource and in turn waits for the other resource where none of the process will be able to continue their execution. As we have seen what is a deadlock and sample examples, we will see what are the conditions that are required for a deadlock to occur. These are the 4 necessary conditions for a deadlock to occur. One is your mutual exclusion, hold and wait, no preemption and circular wait. And as I told, these are necessary conditions. All these 4 conditions are to be compulsorily present if a deadlock occurs. Now, coming on to the first one, mutual exclusion, as the term implies. Mutual, if I have two processes, one particular process may be using a resource. So, when the other process wants to use the same resource at the same time, it will mutually exclude the other one. So, mutual exclusion is used in a case where the resources are not shareable. So, two particular process cannot use the same printer at the same time, for example. When we move on to the next condition, that is nothing but hold and wait. Hold, as we have seen, one particular process will be holding a resource and it will be waiting for the resource which is held by some other process. So, this particular condition, if exists, it leads to deadlock. Coming to the third condition, no preemption. No preemption in the case once a resource is being allocated to a particular process at any cost, you cannot forcibly take out the resource from that particular process until it completes the job. Preemption is a process of taking it out, but here we are dealing with no preemption, meaning that a particular process cannot forcibly take a resource assigned to some other particular process. And the next condition here is nothing but circular wait. So, when we move on to circular wait here, as you can see in this diagram, P1 is waiting for P2. Why? Because P1 wants a resource which is assigned to P2. Similarly, P2 is waiting for P3 because it wants R3, but it is being allocated to P3. Again, P3 is waiting for a resource R1 which is allocated to P1. So, since the first process is waiting for the second, second is waiting for your third, and the third in turn waits for the first process. Since all of them are waiting for each other, this is your circular wait. And for a deadlock to occur, it is compulsory that all these four conditions exist: mutual exclusion, hold and wait, no preemption, and circular wait. Now, you understood what is a deadlock and what are the necessary conditions for a deadlock to occur. Now, we will see how to deal with this particular deadlocks. When I want some strategies to deal with a deadlock, you can either go for deadlock prevention, we can either go for deadlock avoidance or deadlock detection and recovery. Deadlock prevention. As we all know, preventing before a deadlock occurs, we have to see that at any cost deadlock will not be occurring. So, we have to take a measures in order to prevent that particular deadlock. Now, in deadlock prevention, we have four conditions which are necessary for a deadlock to occur. So, if I say that out of four conditions, if one of the condition is not satisfied, then you will not have any deadlock. So, coming to the first condition, I don't want any mutual exclusion. So, when you don't want any mutual exclusion, what we are doing here? We are making all the shareable resources as non-shareable resources. Why? Because we want all the process to use the resource at the same time. But this is not possible in the practical case. So, we move on to the second condition where we will see whether we can eliminate this hold and wait. Hold and wait, as I told you, process 1 will be holding a resource and it will be waiting for the resource of the other process. So, if I don't want this hold and wait, the condition I need to do is either before the starting of the execution, I acquire all the resources and perform the execution, or if you want any of the resources, you need to first of all release the resources which are present with you. But when you want to do all these things, for example, we go for the second case where I am acquiring all the resources before the starting of the execution. What is happening? I am not using all the resources at the same time. So, the resource utilization here will be very less. Now, we will see how we can eliminate no preemption. We told if no preemption exists, there is a deadlock. But here what I want to eliminate no preemption. Eliminating no preemption is you want a preemption to take place. So, when a resource is being used by a process, you will be forcibly taking away the resource from that particular process. But when you are forcibly taking the resource from the process, it may be in the middle of the execution. So, you are stopping the total execution of the process. So, these are all the things which we will be dealing it. Now, when you go for circular wait, as we have seen, last process will be in turn waiting for the first process. So, if I don't have that particular condition, then I can go for eliminating the circular wait. So, in deadlock prevention, we see that any of these four conditions does not exist in reality. But depending on the application what we are using, we cannot go for eliminating them. So, we move on to the next method of handling a deadlock, which we call it as deadlock avoidance. Now, you thought of preventing it, but you couldn't prevent it. So, at least you try to avoid it. So, avoidance can be done. Now, if a process is requesting a resource, first you check whether if I am allocating a resource to that particular process, is it leading to a deadlock or it is not leading to a deadlock. If it is leading to a deadlock, you say that the process is in your unsafe state. And by allocating a resource, if your process still exists in the safe state, you mean to say that there is no deadlock. So, you can go for allocating it. So, at each stage of resource allocation, we apply a Banker's algorithm checking whether the resource can be allocated to the requesting process or not. If by allotting it, if your process is in the safe state, you allot it. By allotting that particular resource to a process, your process is moving on to your unsafe state, meaning that it is leading to a deadlock. So, we don't go for allotting that particular resource. And the third method which we will be seeing here is your deadlock detection. So, we have taken measures of preventing it. We have already seen before allotting a resource how to avoid it. In both the cases, assume I am not able to avoid the deadlock or prevent the deadlock. So, the worst case scenario is the deadlock will occur. So, what I have to do now? I have to first of all detect whether a deadlock, where the deadlock has occurred. So, in order to go for this deadlock detection, we go for constructing a graph which we call it as a wait for graph. Since you cannot construct a wait for graph directly, we go for first constructing a resource allocation graph. So, in the resource allocation graph, just see, as we know, graph is nothing but a collection of edges and the vertices. So, in this graph, the edges are nothing but the lines connecting between a resource and a process, and your vertices are nothing but your resources and the process. And the vertices of your process are represented by circle symbols, and whereas your resources will be represented by a square symbol. Now, if there is an edge from P2 to R3, it indicates that this particular P2 wants this resource. I am repeating it once again. If there is an edge from a process to a resource, it means that this particular process is requesting a resource R3. And if you have an edge from a resource to a process, it indicates that this particular resource is being used by this particular process. One is waiting, the other is holding. So, here R3, P2 is waiting for R3, where R3 is held up with P5. So, this is your resource allocation graph, which will tell you which process is waiting for which particular resource and which process wants the resources. Now, based on this resource allocation graph, we go for constructing a wait for graph. Now, when you see in your wait for graph, the difference between your resource allocation graph and your wait for graph is, you have your edges as well as your vertices, but here the resources will not be reflected as your vertices in the wait for graph. You only have your process and the links between your process. Now, how do we go for establishing a link between the process? I go for a case of P1 and P2. P1 is waiting for R1, whereas R1 is being allotted to P2. It means that P1 is waiting for a resource held by P2. So, you have a direct link from P1 to P2. Similarly, when I go for the case of P2 and P3, P2 is waiting for a resource R5, whereas this particular R5 is allotted to your process P4. So, you have a link from P2 to P4. So, P2 to P4 you have a link. After you establish the link between the process, if there is a cycle in that particular wait for graph, you say that there is a deadlock. So, directly, since you cannot go for constructing a wait for graph, we go for first constructing a resource allocation graph, derive a wait for graph. From the wait for graph, if you have a cycle, you say that there is a deadlock, and if you do not have a cycle, you say that there is no deadlock. So, this is a process of detecting whether you have a deadlock or not. Now, I have detected that I have understood that there is a deadlock here. Now, what is the next step you have to do? You need to go for recovery. You have to take measures of removing that particular deadlock. So, how do we go for actually removing it? So, when I go for recovery, either concentrate on your resources or you either concentrate on your process. Why? Because deadlock is occurring because of resources and the process. Now, if I only concentrate on my resource, either go for using a method of preempting. So, you forcibly take the resources from a process and allot it to the process. So, in that case, at least one process will be able to complete its process, or else you go for rollback. We will be already learning in your DBMS where you go back to the safe state. So, before allocating the process, before getting into the deadlock, you may be entering into a state where it is not under the deadlock. So, you roll back to the previous care where it is in a safe state. These are the two methods which will be taking in case of resources. Either you forcibly take the resources held by some process and allocate it to a process which is waiting for it, or else you go back to a case or you come to that particular condition where before allotting the system was in a safe state. You go for the next method where I will only concentrate on my process. So, when you go for process for recovery, you go for aborting a process. You start killing your process. So if one process is being killed, all the resources allocated to that particular process are now free. So they can be allocated to some other process. You start killing one by one process till your system is in safe state, meaning that there is no deadlock. Or else, so instead of you wasting the time in killing one by one process and analyzing whether the system is in safe or unsafe state, we can move on to the next process where at the starting stage only you abort all the process and try to allocate the resources from the starting. So that may take more amount of time, because whatever amount of work done by all the process, they have to start it again. So these are the different recovery methods which we will be using only after the detection. So by this end of the class, we are able to identify what is a deadlock, what are the necessary conditions for a deadlock, and if a deadlock has to occur, it is compulsory that all the 4 conditions are to be present. And we have even seen what are the different strategies to avoid a deadlock. First we will try to prevent it, next we will try to avoid it, and if both of them are not possible, deadlock will occur. So and it is our responsibility to detect a deadlock and recover from the deadlock.